All right, I'm James. I'm a first-time speaker, long-time listener, and I'd like to welcome you to WebAssembly. It's just in the JavaScript in the browser. First of all, I'd like to thank our sponsors. I'd like to thank the volunteers. I'd like to thank you for attending. I thought it'd just be Sean and I, so here we are, man. Now I'm really nervous. Originally, when I presented to this, I was going to do a topic on Android and Android development, but I kind of took a shining to WebAssembly, and so I asked if I could change my pitch, and they said, "Sure, that sounds good." So here we are on WebAssembly. My name is James. First thing is, this will probably be required this session will require some JavaScript, not much, just to kind of get some glue code. WebAssembly is a new technology. Nobody's making production systems out of this yet. It's a minimum viable product in a few browsers right now. There's no ship code in this demo. I haven't shipped any code in WebAssembly yet, so it's as much an intro to me the last few weeks as it is for you today. So that's kind of what I want to say. Other things is, feel free to raise your hand, ask questions, throw rocks at me, do whatever you have to do. If you don't understand something, make sure you get out of this session understanding it. Either ask me during the session, or ask me after the session, or ask me over beers later. I'm more than willing to talk about this, so obviously that's why I'm here. Any questions? All right, good. We're starting off on a good track. Starting off tripping over my cord. All right, so this is the end of JavaScript. Probably not. I'm just gonna give my big reveal there. We're probably not going to end up with in the JavaScript. Let's see. This is the obligatory slide that everybody must have. My name, my address. I'm pretty easy to get a hold of. So you can remember James or Fish JD. You can probably find me. This is the standard disclaimer. We will be talking disparagingly about JavaScript. Okay? If you know me, you've probably heard it before. I'm not a big JavaScript fan. Actually, I'm kind of a JavaScript fan with ES6, but I don't really like the JavaScript monopoly on the browser. So hopefully we can make some inroads in that. Other thing is, everybody over here is 18. There are some bad words in here. I don't say any bad words. I don't use any bad words in my templates or in my speech, but some of the footnotes have some four-letter words, just so you know. Don't sit too close to the screen either. You might get that one. Okay. So we all know JavaScript has its problems. So, stupid name, let's just face it. WebAssembly has a stupid name too. JavaScript has a stupid name. Should have been called Rhino script or MCA script. Type system, not enough types. No integers. It's programming language. No integers, come on. Type conversion, sorting issues. This goes on. Had to get a little small there. Here we go. And if you're a good JavaScript, this is what you come up with. This is a valid JavaScript function. You can actually write everything JavaScript in 6 characters. And I'll give a demo of that later. If you run this is actually anybody here know what this means? Any real JavaScript programmers in here?
Bad word?
No, it's not a bad word. I said there's no bad words in my demo. Actually, that's a alert box with WBS in it, so.
What?
You can write everything in JavaScript in 6 characters. Of course, if you have 6 characters, you have to have more characters. Binary decimal. All right. There's the bad words down there if you can see them on the bottom. The history of JavaScript. We started out with Brandon, what's his name? Developed JavaScript for Mozilla and Netscape in '95. How many were there? MCA standardization in '97. Wasn't really standardized until '02, but we won't go into that. Ajax in '05. Good news. jQuery '06. Chrome '08. Node '09, which allowed the JavaScript plague to be on the server now. The JIT compiler. I think the first one was in TraceMonkey. I'm not real sure about that. I couldn't figure out when the debugger got into JavaScript, but I think it was like '05, '06. I can't remember when it was late. We had running JavaScript with no debugger was total pain. JIT compiler in '09. JavaScript, the bad parts, released in 2.10. And then 13 is asm.js. Anybody know what asm is? Asm.js is a subset of JavaScript. And it works as kind of a compiler target where you can compile your application to ASM and it will run in the browser. But it'll compile it to a subset of JavaScript. And they like to coerce integers, and there's a cool lecture on it. There's a link to it. And everybody understand ASM? That was a really crappy explanation, I'm sorry. But it's basically a way to target JavaScript as a compiler target. And of course, here we are today, WebAssembly in 2017. Everybody good? Questions? So, what's my next script? So what's WebAssembly? It's kind of an improvement to JavaScript. It is an assembly-like language. It has binary format, and it can be assembled back and forth between the binary format and the text-readable format. The browser reads the binary format. You and I read. Hopefully, if you get into WebAssembly, you'll start reading the realizing you really don't want to look in WebAssembly. You want to compile to WebAssembly. Don't really. Anybody code in assembly language growing up? Yeah. Did you like it? Yeah. It's
last week.
Yeah. Well, yeah, I know you did for us. Yeah.
I've been dealing with assembly code this week.
Yeah. Okay. Well, you had an option when you programming something else.
Yeah, it's usually C, but
the last thing that WebAssembly is the compiler target. Microsoft and Google got tired of paying the JavaScript tax of compiling to JavaScript. It's just, JavaScript does not make a good compiler target. It's got too much going on in the back end. It's interpreted. It was just not made for that. We've been stretching JavaScript as a compiler target for probably as long as it's been out there. And it's just not, both Microsoft and both Google are saying it's time to move on to something else. And that's been kind of the impetus to do something different, because compiling to JavaScript, Microsoft compiles TypeScript. Anybody familiar with TypeScript? Yeah, so TypeScript is compiled to JavaScript. Google's got its GWT project. IDEA's got Kotlin. They're all compiling to JavaScript, and they've all pretty much said enough. Questions? All right, got a question?
I mean, is it a Microsoft goal to basically have TypeScript compiled to this stuff, or will it be something?
I'm not a Microsoft spokesperson, but I would assume at some point they might do that. It's an option for them right now. It'll be an option for them in the future. I think right now they're pretty happy with what they're at, but they're supporting the WebAssembly program, so you got to think they're gonna be on board sooner or later. If not with TypeScript, there'll be a C. I bet you C# will be probably the second or the first language they do. But that's pure speculation on my part. So don't quote me on that. Like I said, we've got support for all the 4 major browsers. So it's one of the first projects of this type that's had all 4 browsers support. We've had Zool, we've had other browser add-ons that have tried to catch on and never have. We'll see how it works, but just having those 4 big names behind it gives it a lot of credibility and a lot of impetus. Here's what I was talking about, JavaScript Overhead. I cropped this slide. This is the semantics for the plus operator in JavaScript. This is everything the interpreter has to do to implement a plus. And it does that every time you do a plus, and if you do it in a loop, it does it every time through that loop. So it's a little bit of overhead. And that's what we're trying to get away from. So this is kind of what we're talking about here. This is the current situation where right now on the server side, with a typical JavaScript, on the server side, we don't do very much work on the little blue circles, the amount of work we're doing. So on the server side, we're not doing too much. We're rendering the page, maybe we've got a template engine in there. But for the most part, the server doesn't do much. But we send the text, the HTML, and the JavaScript, and the CSS over to the client browser. At that point, the JavaScript engine has to parse that code, compile that code if it's using JIT, and then run that code. So we've shifted most of the work over to the client side. If the WebAssembly model now is we shift most of the work over to the server side where we have a lot more resources, we parse and compile it before we ship it across. We still have a small amount of text in HTML and JavaScript to ship across, but then at the runtime, we skip all that overhead. We don't have to parse it, we don't have to compile it, and we run it. So our runtime's faster. What's the best way to make things go faster? Do less. So we're actually doing a lot less work on the browser with WebAssembly. Questions, Nora?
So originally, when I first heard of JavaScript, I mean, that was touted as one of the benefits, is that you're pushing off the JavaScript to the client where the machine's not doing as much, and it reduces the load on the server.
Right.
So is this a new paradigm because servers are so much more powerful than they were then?
I think that's a lot of it. The other thing is, once you get this step done, you can cache it. You don't have to do it every time you serve it.
Okay.
So if you cache in your WebAssembly, it's basically, just think of that as like an EXE or a DLL. Think of it more like a DLL if you're used to that. It's already pre-compiled. All you have to do is send it to the browser, and the browser will run it when you call it. So it's not like we're doing a lot of work every time you're serving the request. You're doing the work before you do that. So you're compiling, you're parsing before the request ever comes. And so once you get that DLL done, anytime you get a request, you just ship it to the browser.
So what you're really talking about is moving JavaScript to a compiled, or instead of a scripting language to a compiled language, whether that's done on the server or wherever the compile's done, but in the browser
Right.
you're running, some sort of, bytecode engine as opposed to a full-blown parser and all the fun stuff you get to do.
Right. But you're saying, you can run JavaScript in here.
Yeah.
The option is you don't have to use JavaScript anymore.
Well, I should say, whatever language you're using to compile to WebAssembly, that's compiled ahead of time or on the server once, and you ship that, just like you do JavaScript today.
Right.
You ship this, like you ship this bytecode, it's a lot more efficient to run. It should also be smaller, so it
Right.
will move across your network smaller and things
Right.
along those lines, so.
Exactly. And the nice thing about it is, if you have a WebAssembly program and it gets shipped down here, it's cached. And so if you've got two WebAssemblies that use the same framework, you only have to download it once. Two different pages, if they both have the same WebAssembly module, they wouldn't have to download it twice. Yes, Nora?
So it's not text anymore when it hits the browser.
No.
So that's gonna play havoc with CSS and all kinds of things.
Well, you're still going to have some HTML and some CSS in there. You're not going to get rid of CSS because CSS is all formatting. WebAssembly is all run actions.
So this is just little pieces of a page, not a whole. It's not.
You can go both ways. You can go little pieces on a page, like my example. My example later in the presentation is just a math routine. I do the factorial example. So you can call factorial and get the answer back. As WebAssembly gets more advanced, you'll be able to call any JavaScript function, any web API that's out there, including VR. There's 100 web APIs out there on the website. VR, I was going to memorize these. Location, notifications, all those things that JavaScript calls now as part of the browser. You'll be able to do that from WebAssembly. Right now you can't, but you will be able to do that soon. All right, everybody good? Big thing is we're shifting a lot of the work from the browser to the web to the server here. One of the things that WebAssembly really relies on is the ES6 module system. Everything in WebAssembly is a module. The WebAssembly itself is a module. A module basically has an optional import statement, which you would import from other modules. Export statement, you usually need one export statement. And it also consists of functions and constants. So your functions would be your factorial statement. And so that's basically what the JavaScript part is basically always going to use modules. So here we go, we've got a module here. This is a simple cube module. You see what we've got our export statement here, and we've got two things we're going to export. We're going to export cube, which is a function, and we're going to export foo, which is a constant. So that's a basic module from JavaScript. So does that make sense to everybody? Am I going too fast? Want me to slow down? Because I feel like I'm going too fast. All right, here we go. What's the next slide? And so if we're going to use this module, we're going to import from my module. We're going to import cube, we're going to import foo, and then we can use them anyway, just like we would in any standard JavaScript. So we can say console log cube, and we'll get 27. And if we log that constant, we'll get some nice floating point constant. So basically what WebAssembly will do is it'll replace this. Instead of being JavaScript, it'll be WebAssembly module. So everything in WebAssembly is going to be based on a module system. You're going to be importing, exporting functions and constants from the module system. Does that make sense? Are you reading out there?
Yeah.
Go ahead.
Like let's say you're compiling something like Java that uses classical inheritance.
Mm-hmm.
Is there going to be some requirement in the compilation that turns it into like a JavaScript prototypal inheritance type thing? Is there like some compromises these languages are going to have to make in order to fulfill this contract of exportability into ES6 or?
Basically, you'll have some kind of export statement in all those languages, and so In C and C++, they already have that kind of statement. Rust has that. Java right now, because there's no garbage collection on WebAssembly at this time, is only static functions. So they'll have an export. There'll probably be some kind of compiler gimmick. They'll have an export function to use that. So yeah, they're gonna have to fudge that somehow. Nobody's done it yet, but they're gonna have to fudge that somehow. So basically, what'll happen? I imagine what'll happen in Java is they'll just run through the function run through the class using reflection and just export everything that's static. So they might even do that for you. There's ways around it, but yeah, you're gonna.
There's going to be some sort of fudging to make things a little bit more. There's still going to be like the shadow of JavaScript in this.
Yeah. You still have to have an export statement and import statement. Yeah.
Okay.
So we'll see how far they can make that disappear, but those are for bigger brains than me. So. How long does this go to? When's this end? 2:15? All right, good. So this is WebAssembly in a nutshell. You've got 4 data types, down 4. 2 integers and 2 floating points. You've got functions. You've got a static linear memory model. 0. It's a 32. I don't know how big it is. Execution, you got your standard data operations, conversions, load store, call direct, call indirect, which is called into a table. You've got your standard block control statements. If, loop, branch, and switch. Notice the one thing that's not in there that every assembly program has is a go-to. There's no go-to in WebAssembly, but they do have the addition of if statements and loop statements. That's mainly so when they parse it, they can validate it in one pass. Not a lot here. You're not going to have to learn a lot. Look familiar, Forrest? Looks like just about every...
About pretty much what I deal with every day.
Every day, yeah. It is a stack-based architecture. It's not register-based. It's an interesting design decision. Any questions?
Will this change any of the kind of issues with loading point numbers in JavaScript with like non-commutativity and like decimal numbers?
I think it'll like NaN equals to not equal to NaN. I think it'll solve that.
Okay.
But it will not solve standard.
There's 2 integer types up there.
Yeah. There are 2 integer types up there.
So that 64-bit integer, that I-64 should be able to represent pretty much anything you're to throw at it.
Right. But yeah, I think he's right. But they're not going to get rid of the problems that are inherited with 745 floating points. You're still going to have not a number. You're still going to have infinity. You're still going to have things if 0.1 plus 0.3 does not equal 0.4.
Right.
Yeah.
That's just inherent with floating
That's
point
inherent with
numbers.
floating point because of the way you're coding it, that you have a mantissa and an exponent, and there's just some numbers you just can't represent in floating point.
Right. So, but the numbers you can't represent in floating point, at least you have the option now of going integer.
Right.
Or if you want to make big decimal, you could. You wanted to make, which is binary coded decimal, you could. Boy, so which you couldn't really do in very well in JavaScript. So there's not much here. It's just a pretty simple, extremely simple virtual machine. All right, questions? I think we're good. All right, so this is the compiler target. This is how C compiles right now. You got your front end, you got your optimizer, and you got your back end. It's an end-to-end relationship. You got in on the front end, you got in on the back end. You can mix and match as you want. The cool thing is, WebAssembly goes right here. I should have penciled that in. I didn't think about that until right now. So basically, any crazy language you want to get that will compile to LLVM, you'll be able to compile into WebAssembly. What's LLVM? LLVM used to stand for low-level virtual machine, and that's just what we saw on the previous slide. It's 15-year technology. It's been around forever. It's basically what the compiler writers use for the automation to optimize. It's a virtual assembly language that sits in between the front end and the back end. So for compiling, we start with our source code. That'd be C, C++, Rust, static Java, whatever language you feel like running. And then with C, well, this is a C example, we're going to compile with the Clang compiler. The thing about the Clang compiler is it works with LLVM as opposed to GCC. You get the LLVM, and then you compile that with a tool called Inscription. I can never say that word. And Inscription is a compiler that compiled the ASM.js, which I was talking about. And so they just took that same compiler and extended it to WebAssembly. So, and it also, Inscription also adds some things in there. If you're a C programmer, it's got standard I/O, standard input, I don't know, files. And so it kind of emulates that in JavaScript for you. To help the C compilers, C writers. And then, of course, you get your WebAssembly module, and that's what you ship across the wire to the browser. All right, so here's my example. This is on the left-hand side, this is the C code that you get. Am I talking too loud? Can everybody hear me? Too loud? All right. All right. So this is standard C code for the factorial function. You compile it, and this is the LLVM for it. So it's kind of an assembly language. They call it an abstract AST. I should have written that down. So you can, as you look, you can actually see the conversions. You've got if statements, you got gets, you got add ones, you got multiplies. It goes on down a little bit farther. I think it's about 100 lines or so. So that's kind of what you're getting. Questions? Don't worry, I don't think any of us will ever work in this. If you're ever working in this, you know you got problems. So, but it's there, you know. C always compiles to assembly, and I know when I was working in C, if I popped down to assembly, I was in trouble. So, all right. So, what are the advantages of JavaScript? Basically, of course, just like in real estate, speed. You've got near native runtime performance. You'll see numbers in the 1.2 to 1.5 runtime speed. So you're just a little bit faster than, a little bit slower than actually running it on runtime. Smaller, faster load and transfer times. That'll be a big boom, especially as we move to mobile. People are paying more for, people who pay for data over the wire will thank you for that. It's secure, it runs in the same sandbox and security model as JavaScript. So we won't have to educate, hopefully we won't have to, hopefully it'll be secure, it'll be adopted that way. It'll be easy to adopt because it'll be a secure model. And it'll be open source, so go out there and look at the WebAssembly, make changes. Code's out on GitHub if you want to look at it. Questions? Yeah?
So how do you interact with the web page? Is there DOM access or what's
Well, they're getting to the DOM access right now. Right now, it's pretty much just function calls right now. Like I said, it's a MVP. they're gonna put DOM access into it, and all the, what did I say, all the APIs, they'll make a module for all the APIs. So if you wanna do location, you'll call the location module. If you wanna call the DOM, you'll call the DOM module. If you wanna call other JavaScript, it'll be a JavaScript module and you call that.
So you will be able to access the DOM from within the WebAssembly as opposed to having JavaScript calling into WebAssembly and then.
Eventually, that's what they're talking about, right. Eventually. Is it there now? No. Will it be? We cross our fingers. Or you can go do that. That'd be a good job for you. Does that answer your question?
Yeah.
Any other questions? I'm here for you, man, so let me know.
Does this run in the main thread?
I don't know the answer to that question. That is a good question. Good question, thanks.
So,
Go ahead, somebody have a question?
so at some point, you'd literally be writing like DOM manipulations and all that stuff in C or in Java or whatever you're basically.
If you wanted to,
Yeah.
yeah, you could do that. That's kind of where they're headed. If we see that, we'll see it, yeah. So where's the roadmap ahead? This is off the WebAssembly docs itself. Threads, they're going to start having your own, be able to manage your own thread. Single instruction, multiple data. I don't know, those guys, people that love that stuff, and they have good reason for it. Like I said, JS and DOM integration, call back and forth between the two. That'll be next. And, oh yeah, that's just my footnote there. The cool thing will be, when they get that done, it won't just be crazy math libraries like I'm showing today. Any questions? Comments?
I was just going to say, what this is interesting to me for is that, like today I use InScript and I have a compiler that I run in a browser just because I'm very resource constrained off back-end device. And that's C. So basically I compile C to JavaScript and call it from JavaScript.
Right.
And although it is very inefficient, it's fast enough for what I need, but it seems horrible to be taking a fast C compiled language and LLVM and running it through InScript, and then you end up with basically it being interpreted, bytecode being interpreted in JavaScript amazingly fast, but for what it is. Whereas this seems like really this is a tool to help integrate it more closely with JavaScript browser things. So that's probably fair to say.
That's a very good description.
Okay.
That's how I would interpret it, yeah. Does that make sense to everybody?
Do you know if they're planning to create a GC for this as well?
A GC, garbage collector?
Yeah.
Yes, it is on the to-do list.
Oh,
It's
right
probably
there.
the next step down. It's got a little picture of a unicorn right next to it on the to-do list. So, wow, that was a joke? Okay, good.
I haven't looked in detail at WebAssembly, but it would occur to me that, there's I'm going to say the bytecode engine piece of this, which sounds like what they've got done.
Right.
And then there's all the libraries that live around it. It's like when you compile C, there's the actual making machine code work, and then there's the standard I/O and everything else, and how do you talk to the machine and all that type of stuff. And it sounds like that's what's not complete and still is somewhat up in the air.
There's a lot of work left, yes. A lot of work left on that, but
Which includes memory allocation and manipulating the DOM and all of those type of pieces. So.
all right. Well, we've got some after lunch snappers here, so kind of interesting. Yes, Nora.
So do you think this is gonna, or could totally replace JavaScript, or is it a next step of JavaScript as far as an addition to?
Anything I would say on that would be conjecture, but I will say it will probably lead to, you'll use JavaScript, what JavaScript is really good at, which is validating forms and maybe doing a little spinner stuff. You'll use WebAssembly at, did I say? That's what it was designed for. I mean, that's what, and we'll use WebAssembly and other languages for what they're good at. C is really good at computation and doing math. Java's good at whatever Java's good at. I'm not sure what that is. And I'm a Java programmer. So I think we'll be able to use, I mean, basically what we'll do is we'll be able to break away from that JavaScript monopoly. JavaScript will still have its place. It's not going anywhere. There's too much money and too much time poured down the JavaScript hole. We're not going to dig ourselves out of that. We're going to look back upon JavaScript 10 years from now and just shake our heads. It'll go like we do at 5250 terminals right now. What were we thinking? Why did we stay for that so long? It was so painful. So much. I'll get off my soapbox now, but we're going to look back upon it and shake our heads, I'll guarantee you. Questions? Yeah, go ahead.
Are we obsolete yet?
JavaScript programmers? No, you just have to retrain. There's been one language that had a monopoly and lost it. Who was it? Anybody?
Fortran.
No, Fortran never had a monopoly. COBOL always. COBOL, you can run COBOL on any machine that Fortran ran.
Basic.
Think more recent. Think Apple. Think iPhone.
ObjectiveC.
ObjectiveC. This is the ObjectiveC lot. This is what happened to ObjectiveC. iPhone was released in 2007. Swift was released in 2014. Here's where we're at in questions. Oh, my slides are out of order. All right, well, I guess I missed that slide. So JavaScript was released in 2014. You can see what happened to it. It returned to its natural growth towards after 2014. You can still see that slowly growing. But once Swift was put away, once Swift was in place, the monopoly of iOS, ObjectiveC kind of went away, and it was a definite pain point for iOS developers. Make sense? Any questions? All right, we got plenty of time, so feel free to ask questions. Questions? I already asked that, didn't I? All right, so that's it. That's kind of the ObjectiveC thing. That's not me, man. That's the guy next door. So I did do a couple demos here. They're pretty short and sweet, so we're gonna have some time.
What's that?
All right, everyone put a red paper in their box.
All right, well, this is, you've heard of JS fill, this is WebAssembly fill. This is where I cribbed my example from, so I got a mouse here. So of course I use the factorials demo. That should look familiar to you. That was in the demo. Here's this assembly code. And I don't know why they do Firefox assembly here, but they do that. So basically, that's Explorer, kind of how you do it. You can see other demos here. I don't even know what these others do, but the nice thing is you can compile it, and it tells you what you got. And then you can run it in WebAssembly fill. Here's WebAssembly fill. You can build it here. You get the same code that you saw here. Imports template. You can import it. There's the code, but there's what it actually looks like in binary. If you get there, if you get to that part, you know you screwed up. So. But anyway, basically at this point, you can come over here and you can type, if you run it, you can download the text, or you can actually download the WebAssembly and serve it if you wanted to. So that way you don't have to have a C compiler on your machine. Kind of a long way of developing, but when you're just doing a demo like I am, getting the client compiler was a total pain. So if I wanted to actually call this code, it takes a line of code, and I'm not daring like that other guy. I actually have it copied here, so all I have to do is paste it in. Hey, it worked all right. But then I have to build it and run it. So we're gonna do the factorial 7. Any guesses? Nobody knows what the factorial 7 is off their head? It's what's it say down there? 5040. Yeah. So, can you read that? Yeah, 5040. Yeah, let's see. How do I do that? Control. There it is. So, basically, like I said, we've got our module there. I don't know how it figures out what my export is. Like your question was, how are you going to do exports? It figures it out somehow. I'm not really worried about it. But basically, over in the JavaScript, you've got the WebAssembly command, and you instantiate. And then we don't have any imports. You can have imports, but then you get an export. So you get an export. You get an export piece, and one of the things that exports is the linear memory that was part of the WebAssembly package. That was back on slide 12. And then what we do is standard log statement. And then here we take our export, and instead of doing memory, we do our function, which is FACT. So this runs like 10 times faster. If you run this 1,000 times, it'd be 10 times faster than, a whole bunch faster than running it through JavaScript. Does that make sense to everybody? Speak now. Anybody, any JavaScript programmers, ears bleeding back there in the back row? No? Okay. My jokes are starting to wear thin, I can tell. All right, good question. I already asked that question. So I actually put this into my, code here. So if I, instead of just doing it on the WebAssembly, I could actually do it and see how it would serve up. Really exciting, but prove to myself that I could actually, if I wanted to, do production code, download that, serve it up, and make production code out of it if I wanted to. If I want to do a factorial function, I'm set, you know. But as you can see, you can take that and go run with it anywhere you wanted to. So does that make sense? All right. Well, we're still running ahead of time.